Hello YouTube, welcome back to my channel. So in today's tutorial, we're going to go over a very simple to do project. You're going to be performing data analysis, analyzing the Spotify songs data set. So at the end of the tutorial, we're going to build a something very simple to this. So we're going to perform all this analysis, analyze the different data sets, and then answer a lot of questions that we're going to write ourselves and compute ourselves, and then try to use data analysis to answer those different questions. Okay, so if you're new to the channel, please kindly consider subscribing, liking this video, and sharing this video with anyone who you think might find helpful. So let's get started to it. So guys, so the first thing we need to do is actually get the data set that we need. So this is called data sourcing. Okay, so if you're new to data analysis or you have not done any data analysis project before and you're interested in the beginning part of data analysis, I have a whole tutorial where we went over the tiny little details of data analysis. We went over the tiny little data analysis, tiny details of or concepts of data analysis, and we went over what is data sourcing. So the first thing we need to do to perform data analysis is we need to outsource our data. This could be either using a public data repository that you're going to be using in this case, or you can use a private repository. So the first thing we need to do is really get the data that we need. So I'm going to go ahead and get this data. We're going to get this data from Kaggle. So I'm going to click on this link, and the link to this notebook is going to be found in the description. There's going to be a link to my GitHub repository where you can find this specific notebook. So the first thing we need to do is really get the data that we want. Okay, first we need is actually get the data that we want. So we're going to be using this link, Spotify data set. So you can just click on the download button, and then it to download for you a zip file, and then you can extract the zip file and obtain the data from it. So you can have to extract the zip file, and I kept in a folder called datasets, and I named it Spotify_data.csv, but by default it's just data.csv, but I renamed it to Spotify_data.csv. So if you guys don't know what Spotify is, I think it's the world's largest music streaming platform. It has a lot of musical content that you can find and listen to. You can also have a paid account, also have a free account. Okay, so let me know in the whether you guys are familiar with Spotify and whether you have a paid account or a free account, and what's your most favorite music. Okay, we're going to do all that analysis. So let's look at the data that we have. So this data was collected from 5 years back, so it's a bit outdated. This was collected from 5 years back. So we're just going to perform some simple data analysis so that you guys can learn the different concepts that you use when performing data analysis and practice more on data analysis. So let's get to it. So the first thing you need to do before you begin analyzing a data, let me ask you a question. Why do you think you are analyzing the data in the first place? Because you want to find out a certain amount of information, right? So the important thing is to write those questions down that you wish to answer while performing data analysis, so that you can go straight to the point and look and find what you're trying to look for, rather than just beating around the bush and trying to do plotting of different graphs and other things that might not be necessary to you. So just list the questions that you want to answer. Even if there are 2 questions, just list them and try to answer those questions first. Once you're along the way of trying to answer those questions, you'll find more interesting things that you might be interested in, and then from there you have multiple things that you want to answer, and then you perform a good data analysis in that way. So I have listed all the questions right that you're going to be answering. Okay, so first of all, let me just keep those questions to be unanswered for now. Let me just leave them unanswered for now. So I'm just going to remove the ticks. Okay, so you consider those questions unanswered for now. Okay, so you can see our checkbox right now is currently empty, so we don't have those questions answered. So let's go ahead and try to answer those questions. So let's go ahead and actually load in the data set that we need. But first of all, let's go ahead and import all the things that we need. So I'm just going to import it down here. So I'm going to import Pandas as PD, import NumPy. Okay, not SumPy, is actually NumPy as NP. Import Seaborn as SNS. Import matplotlib.pyplot as PLT, just like that. So I'm going to go ahead and run this. So I'm going to also go ahead and set some information. I'm going to say sns.set_style, and I'm going to set the style to be dark grid. Okay, just for our plotting. Okay, so I'm just going to say dark grid, just like that. So once I have that set up, I can go ahead and actually load the data that we need. So let's go ahead and actually load the data. So I'm going to keep a comment here and then say load data set, just like that, and I'm going to do df, and it's going to be pd.read_csv, and then if we find the path to that data, so it's going to be /datasets/ I call this Spotify spotify underscore data.csv. Yeah, so I can do that and get this people visualize that, check that data frame. So this is a data frame right here. So I want to get rid of this unnamed column, so I'm just going to go ahead and remove that. So I'm going to say df.drop. So df.drop, and I'm also going to drop the unnamed column, which is this column right here. I don't need that column, so it's going to say unnamed colon 0. And then I want to go ahead and drop it, so I'm going to say axis is going to be 1 because it's a column. And then I'm going to say in place is true because I want to remove it permanently, and then run that. So you have that information right here. So you can so just do a df.head and then get that df.head just like that. So once we have this right here, we have the data frame right here. You can see you have these different columns right here. So you have the target column, the artist column, the target column, the song title, the acousticness, and all this. So how do you know what all these columns mean? So for now, let's leave that for now. Let's go ahead and try to do some data cleaning on the data before we come back to analyzing the data. So we'll come back to identify what all this means just in a second, but for now let's do some data cleaning on this data first to clean the data. So let's check for if you have any missing files. So I'm just going to keep a comment here, and this is going to be data cleaning, and this is going to be df.isna.sum. Let's check for any missing values. So I just check that we don't have any missing values, so our data set is quite clean. Okay, so you can also do a df.info to check the different info of the different columns. So different df info, and then just run that. So we have this information right here. So we have the column name and then the different data types of those specific columns. Okay, so once we have that, I can go do a df.shape. So I can do df.shape just like this, and this return to me the shape of that data frame. So we have 2017. Okay, 2017 rows, and then you have 16 different columns. So 2017 actually for the year of 2017, and that's the year that the data was collected, because 5 years back, right, if my math is not wrong, that should be around 2017. So once I have that, I can also check the different columns that I have. So I can df.columns and then run that. You can see we have these different columns right here. So we should have 16 columns in total, and you can check that by doing length and then df.columns, and you can write, you see you have 16. So great. So now that we have that, let's go and check for I've already checked for missing values. I've already got the df.info already, which are the different columns along with their data types and how many rows they have and all of that information. And we also know that we have no missing data in our data set, so we are quite good. Yeah, that's all we need because the data set is quite clean. I've already looked at it and it's quite clean. Let us not waste more time with this data cleaning. Let's jump into the analysis part. So first of all, let's look at a statistical summary of our data. So I'm just going to do df.describe, and let's look at the statistical summary of our data. So this is our data here, and give us the statistical summary of our data. So we have the percentiles and all these marks, the mean, the standard deviation for each of those numeric columns, right? So you can see that for acousticness, 75% of the songs had acoustic of 0.65 or below, and then 50% had a 0.06333 or below, and stuff like that. So this is all the information that you need, the marks, the standard deviation, right? So the mean acousticness was around 0.876. okay, so that's all this information, the duration, and all this information can be found. How do you know all this, and how does it mean? Like the key, what does the key mean? What does liveliness mean? What does loudliness mean? What does mode mean? What does pitchiness mean? Tempo, time signature, valence, and target. What does all this mean? So that's why we need the documentation for that data set, right? So if you can go and read about the documentation right here on this link, and I'm going to keep this link. It's going to be the link to this link right here, so you can click on it and go to the Spotify official documentation, and you can read about the different columns, like the loudliness, what it means. So loudliness actually is a confidence measure from 0 to 1 of whether the track is acoustic, and 1 represents a very high confidence track and is acoustic and stuff like that. Yeah, so we have all that information right here. So you can analyze it, and you can read more about it, each of these columns that we have here, and then find out what they mean and what the values of each of them means. For acousticness, is a floating number from 1 to 0.5, and 0.5, sorry, from 0 to 5, where 1 is the loudest acousticness, and 0 means the lowest. Okay, and you have all that information right here: the energy, the duration, which is the duration of the song in milliseconds, the key, the liveliness, the loudliness, the speechiness, the tempo, the track reference, and all this information you can find about here. So once I have all that information done, you can analyze all that information. Let's go ahead and try to analyze our data. Let's try to perform some analysis on the data. So I'm just going to make this markdown cell. You just select the end of the cell, the click on the leftmost part of the cell, and then just press M on your keyboard to turn that into a markdown cell. So I'm just going to write here data analysis, just like here. So in here, what I'm simply going to do, I want to go ahead and analyze our data, right? But you need to have a set of questions that you need to answer, as I told you earlier on. So I have these questions right here, and I also have the self-assessment questions, where in these assessment questions is what you use to test yourself after this tutorial, because what's the point of learning if you never apply your skills? So I'm going to leave these ones for you guys to test on, but for now I'm just going to go ahead and address answering this question. So I'm just going to copy this question and go down right here. So let's go and make this a markdown. So press M and then make this markdown, so and paste that question. Oh, I didn't copy it, so let me just go and make sure I have that copied properly. So I'm going to copy it and then move down here and simply paste it here and run that. So we want to find the top for the top 5 popular artists. So what is to do, I'm going to say top underscore 5 underscore artists, and this is going to be the following. So it's going to be df. We're going to simply go ahead and group by, and you're going to go ahead and group by the artists, and then I'm going to get a count of that. So I'm going to count. So I'm going to group by the artist and then get a count, and I'm going to sort these values, and I'm going to sort by the song title, song underscore title, and then I'm going to say ascending is going to be a false. So I want in descending order from the highest to the lowest, and then I want to group by group by the song title. So song underscore title, and I want to get the top 5. So the top 5. So yeah, so that's all I want, and I can just simply do a top underscore 5 artists. Just run that and let's see what we get. So we get back this right here. So we get the top 5 most artists back. The first one being Drake, and then Rick Ross, and then they have the most popular songs in this data set, right? So we have the most popular songs, and Drake has 16 songs, Rick Ross has 13, and Disclosure had 12. Backstreet Boys had 10, and then Walk the Moon has 10. Okay, so you can actually go ahead and visualize this data. So to visualize this data, we're just going to say top underscore 5 underscore artists dot plot dot bar h. I'm just going to do a bar plot here, and then I'm going to plt dot show, just like that, and I can simply go ahead and run this. So this is going to plot for me a simple graph showing me the information that I have. So you can see Drake is the most popular artist because it has the most songs on this playlist, and then we have Rick Ross, if you can remember Rick Ross, okay, and then we have Backstreet Boys, Disclosure, and Walk the Moon. So you guys, if you tell me your most favorite artist among these guys in the comment section below. Which one of the most favorite guys here are your most favorite artist? Okay, so great. So let's get the list of the top most popular artists, okay, basing on the songs, how many songs they have. So we have Drake leading this list right here. So great. So let's move on to the second question. Now that you have that question answered, let's actually make sure that we indicate it being answered. So I'm going to keep an X here and then run that. So that shows that question is answered. So now I want to answer a question of the top 5 loudest tracks. So I'm going to go ahead and copy this. So copy this, copy that, and then run this. So I'm going to get the top artist with the top loudest song. So press M here and then just keep this and paste it here. So top 5 loudest tracks. Okay, top 5 loudest tracks. To get that information, what you simply need to do is, first of all, you're going to get just the loudness and then the song title, and you're going to sort basing on basing on the loudliness of the song. So I'm going to say top underscore 5 underscore top 5 loudest underscore tracks, and this is going to be the following df, and you're going to go ahead and get the following column. So I'm going to get loudness column, and then I'm also going to go ahead and get the song title column, so song underscore title. Yeah, so once I have that, I want to go ahead and sort these values. So I'm going to say sort underscore values, and then I'm going to sort by, and I'm going to sort by the loudness. Okay, and let's run this and let's see what we get. So I'm going to copy this and simply paste it here and run this, so we get this information right here. So I want to get the top 5, so I want to go ahead and get the top 5. Now you can also actually order this in ascending to be false. We want the descending because we want the highest to the lowest, so ascending is going to be false, and I want the top 5. So if I run this, I want the, yeah, you can see the loudness of the song. So I can just go ahead, okay, this actually should be in descending, right? This should be true. And why am I saying true? Let me just get the top 5 and I'll explain it to you just in a second. So this is going to be top 5, and then run this information. So I have this information right here. So if you go back to the official Spotify API documentation and then look at loudliness. So loudness, overall loudness of a track in decibels. So decibels loudness values are average across the whole track, and it starts from -60 and 0. So I did a quick research on this because I don't have any specialization in sound and the fact like that. So I checked the 60. I think the more negative the number is, the more louder it is. So negative 0.097 is actually more louder than negative 31.367, which is here. That's why I'm ordering in ascending order from the lowest to the highest. Okay, so the more lower the number is, the more louder it is in decibels. That was my research. In case you guys think otherwise, let me know in the comment section below and actually provide a reason why you think so. Okay, so once I have that, I want to go ahead and show this. So I'm going to do a PL, I'm going to visualize this. So plt.figure, and I'm going to say fig size, and the fig size is going to be the following. So we're going to go ahead and specify 12 by 7, which is going to be the fig size, and I'm going to do a simple sns.barplot and I'm going to say the x, and the x is going to be the following. So the x is going to be the loudness of the song, so loudness, and then the y is going to be the following. So the y is going to go ahead and be the song underscore title, and then you can specify the data, and the data is going to be what we just copied right here, which is going to be this track right here, this data frame. Yeah, so I can go ahead and specify the title to this, so I can just say the title to this. Okay, so just say here, and then I'm going to say the plt.title, and the title is going to be top 5 loudest tracks, just like that. And again, simply do plt.show. So I run that, and I can see the graph. We have the graph plotted right here. Okay, so the most loud song was this one by Relic Pieces, book 1, blah blah, I re-enter and stuff like that. So that's the most loudest song, and the least loudest song among the top 5 loudest was Illinois. Okay, I don't know who is this guy. If you know him, kindly let us know in the comment section below. So once I have that plotted, I can simply go ahead to the next question. So let's look at what's the next question on our list. So let's make sure that we have the current one answered. So I'm going to keep an X here. So the next question on the list is the artist with the most danceability songs. So I'm just going to go ahead and copy this information, and then let's go ahead and try to answer this question. So I'm going to make this a markdown by pressing N, and then make this okay, artist with the most danceable song. So we can just go ahead and actually get that information. So you can say top underscore 5 top 5 underscore artists danceability, danceable. Let's just say danceable underscore songs, and this is going to be the following, right? And this is simply going to be df, and then you want to get a couple of columns. So we want to get the dance ability of the song, and we also want to get the song title underscore title, and also want to get the artist of that specific song. So I can say artist, and then I want to go ahead and do something. So what I want to go ahead and do, let me actually look in here. I already have this on my GitHub repository, which you guys can find the link to in the description. So here it is. So I also want to go ahead and sort this by danceability and then put it in descending order and then get the top 5. So sort by danceability. I'm going to say dot sort underscore values and then by is going to be by danceability, right? So danceability, and then ascending is going to be false because we want it descending, and then I want to get the top 5, so top 5. Okay, that should return to me the top 5. So let me just delete this. Actually supposed to square brackets and then the top 5. Okay, so let me just break this down into multiple lines this way, and I can simply copy this, paste it right here, and then I can run this all. So we have the top artist with the most danceable song. So if you want to read about danceability and what all that means, so I can just go to the official documentation and say danceability describes how suitable a track is for dancing based on combination of combination of musical elements including tempo, rhythm, stability, beat strength, and the overall regularity of that specific song. So the value for 0 is the least danceable song, and then 10 is the most danceable one. So the 1 is the, sorry, not to 10 actually, 1. So 1 is the most danceable one. So according to the top 5, you have the 0.984, which is the most danceable, and as you go along it decreases. Okay, and that was by Flashwayne, an artist called Ben. Remember, I don't know him. If you know him and you're a fan of him, let us know in the comment section below. And we also have Justin Bieber being the second, which is Sex Back. I don't know that song, but I know the artist. And then we have the least one being at least among the 5 being Ice Ice Baby by Vanilla Ice. I don't know Vanilla Ice. Yeah, so we have all that information right there. So once we have all that information, let's go ahead and try to visualize this information. So do the same using the plt.figure figure, and then we'll find the fig size, and then the fig size is going to be as follows. So it's going to be 12 by 7, and then after that I'm going to do bar plot. So I'm going to do a bar plot, and I'm going to provide the x to be the following. So the x is going to be danceability. This spelling is tricking me off. So danceability, and the y is going to be the artist. And then we have the data, and data is going to be this data frame right here. So I'm going to copy this and simply paste it right here. Yeah, that's all we need. And then I can just go ahead and specify the title. So plt.title, and the title is going to be the following. So the title is going to be artist with most danceability song, right? So we're going to say most danceability song. So danceability song. Okay, song just like that, and you can simply do a plt.show. Okay, get that right. So plt.show, and then run that. So here, and then run that. So that should return to us the graph. So you can see we have visualized that this information right here. We have visualized it here, and the most danceable song is by Ben. Remember, right? So once we have that done, that's all we need. We can go ahead and actually do the instrumental. Let's see what question is next on the list. So I'm just going to go in here and make sure that we tick the one that we just answered. So let me just make sure that it's marked. So X. So good. So the next question is the top instrumentalness track. So I'm just going to copy this question, and then we're going to use it. So let me just paste it here. So I'm going to make this a markdown M, and then make this a title. Okay, and then paste it here. So top 10 instrumental songs, instrumental tracks or songs, whatever. So what we need to do is actually need to get some couple of columns. So I'm just going to say create a data frame here. I'm going to call it top 10 underscore instrumental underscore tracks. It's going to be df, and I'm going to get a couple of data columns. So I'm going to create instrumentalness, and then I want to get the song underscore title, the song title, and then I also want to go ahead and get the artist of that song. Yeah, so once I have that, I want to go ahead and sort this value. So I'm going to do dot sort underscore values. So I want to sort by, and I want to sort by the instrumentalness, right? And then I want to say ascending is going to be false, because you want from the highest to the lowest, so false, and then you're going to get the very top 5. So get this, get me the top 5, and then we can. Okay, we have an error here saying instrumental is not defined. So you know what, I'm just going to go ahead and actually copy this from here. So instrumentalness, I think I got the spelling wrong. I don't want to waste time figuring out what was wrong, so I'm just gonna paste this right here and also paste it here. Yeah, so once I have, I can break this into multiple lines. I want to copy this and then paste it here at the bottom. So paste it here and then run that. So we have the top 5 most instrumental songs. What is instrumentalness and what does it mean? So if you go back to your field documentation, you can read about it. So predicts whether a track is a combination of vocals or sounds are treated as instrumental in this context. So rap or spoken word tracks are clear vocal. The closer the instrumental value is to 1, the greater the likelihood the track contains no vocal content. Values above 0.5 are intended to represent instrumental tracks. So anything above 0.5 is actually instrumental, and anything below that is not instrumental. Okay, so once we have it, you can see you get the top 5 most instrumental tracks. So what you can simply go ahead and do is actually to visualize this once we have it done. So we can visualize it if you want. So let's go ahead and try to visualize it, and to do this you can just create a simple pie chart and visualize it. So I'm going to say plt.figure, and then I'm going to say the fig size, and the fig size is going to be 12 by 7 as usual, and then you're going to do plt.py, and then you're going to specify the values here. So we're going to say x, and x is going to be instrumentalness. So instrumentalness, and then the data is going to be here. So I'm going to copy this data frame, copy it, and simply paste it here. And yeah, we can also specify other factors. So I don't have this memorized in my head, so I'm just going to get it from here, which is this right here. I'm just going to copy this and use it here. So this is going to put the values that we have in here. So that's what this is for. So I'm going to simply paste it in here, and then you're going to specify the labels, and the labels is going to be this data frame, the labels dot songs. So I'm going to get this, copy this, and simply paste it in here, paste it here, dot song underscore title. So we have an error. It says I got unattended labels. Is it label? Let me see. Is it label? That's how it's spelled. Okay, I got the spelling of label right, wrong. Here, yeah. Okay, so now instead of doing this again, let's do a plt.show instead of getting all this. So plt.show. You can give it a title if you want, that's fine, but you can see it's according to the instrumentalness based on these 5 values. So this is the most instrumental one that has 20% of all those values. This is only based on this top on these 5 ones. So if you want to compare maybe against all the graph, all the plots, or want to actually visualize these specific values, then you can simply go ahead and use a bar chart, and that will do it for you. But I'm using a pie chart because I'm comparing it against the top 5. Okay, I'm comparing each song against the top 5. So great. So once we have that there, let's move on to the next question. So let's go ahead and move on to the next question. So let's make sure we have this current question ticked as answered. So just here I'm going to tick this as answered. So go in here and press X here. So we have that answered. So the next one, which is going to be the last question, you want to do a multiple feature plot on all this based on the tempo, the loudliness, the acousticness, the danceability, the duration, the energy, the instrumentalness, the liveliness, the speech, and then the valence. So what the heck is the valence? So the valence measure from 0 to 1, describing the musical positiveness conveyed by a track. So the positiveness conveyed by a track is the valence. Okay. So let's do a feature plot. So I'm just going to copy this, and I'm going to scroll to the very bottom right here, and I'm going to make this a markdown, and then simply paste that in there, and then paste here. So to do this, I have a list of data that, columns that I'm interested in, and all the columns are the ones that we listed here. So the ones that we listed here is what I'm interested in. So these columns values that we listed here. So I'm interested in all of this. So I just made a list of all of those, and I'm just going to copy paste it here, and I call it interested features. Okay. So using this, you're going to plot a histogram or a distribution plot of all of this, basing on whether the song was liked or whether the song was not liked. Okay, so to do this, you can do this manually for each of those values instead of this list, or each of those features instead of this list. But I'm going to use a for loop, right? Because that's what for loops are for, to do things that the same thing, repetition of things. You can just use a for loop for them. So I'm going to use a for loop for this. So I'm just going to copy this right here and simply paste it. Make sure I get this right. Copy it and simply paste it here. Okay, so yeah, so once I have that, I can create the positive data, and these are the songs that were liked. So I want to get df instead of df, I want to get df in which the target is equals to 1. These are the like songs, and I want to get the features, the feature underscore column that I'm interested in. So I want to also do this for the negative data, and these are the ones that are not liked. So df and then df. In here I want to go and specify the target, and the target here is going to be equals to 0, and then I want to get the feature feature underscore call right here. So it's going to return me the features, and using these features I'm going to go ahead and create a figure. So I'm going to go ahead and create a figure just like this, and I'm going to find the fig size, and the fig size is going to be the following. So the fig size is going to be 12 by 7 as we did, and then I can just go ahead and actually plot the graph. So I'm going to sns.distplot. So I wanted to use a hist plot for a histogram, but the hist plot are not actually available in modern Seaborn. For some reason they have replaced the dist plot. So I'm going to use a dist plot. So I'm going to use the post data, and then I'm going to say bin. I'm going to specify I want a bin. Bins is going to be 30. Okay, and then we can specify the label. So the label is going to be positive, because it's positive data. Okay, and then I want the color. I can specify the color here to be green, just like that. Yeah, that's what I want. So this is supposed to be a string and not just green. What's green? It's not defined, right? So green. And then I also want to sns.distplot. I want this negative data, and then beans are going to be 30. Beans are going to be 30, and then the label is going to be a negative one, and then the color is going to be a red one, because if the song is not liked, then you can think of it as red, down, thumbs down, and stuff like that. So once I have this one, so I want to do a plt.legend to show the legend, and then you display the location of that legend, and then the lock is going to be upper right. Okay, and then I can do plt.title. So the title is going to be different for each plot, right? So I'm going to be using an f string right here. So I'm going to say positive and negative. This is going to be a histogram. So histogram plot for. Okay, so you can choose, instead of saying positive and negative, saying dislike and liked or something like that. So 1 actually means that it's liked, and 0 means it's not liked. Okay, so we're going to say a feature. This is going to be feature underscore column, just like that. I can do a plt.show. So if I have no error done, then it should plot for me all those graphs right here. So as you can see, more graphs are being plotted and stuff like that. So let's make sure it is big. Okay, here. So we have all the graph plotted here. Okay, so let's go and try to analyze this one after the other. So this is a positive and negative histogram plot for the tempo. And what's the tempo? So you can go back to official documentation and read what about tempo. Tempo, the overall estimated tempo of a track is track in beats per minute. So beats per minute, that's what the tempo is. In musical terminology, tempo is the speed or pace of a given piece, and deviates directly from the average beat duration. Okay, I'm not really a music guy, so I don't really understand what this means, but I just know that it's talking about the speed or tempo of the pace of the music. So okay, let's look at what people like the most. So the green ones are what people like, right? The positive ones. I think people like a tempo of around 140, 130. Between that tempo is good, but when it is too fast, people begin to dislike it, and when it is too slow, people don't also like it, the pace of the music, that is. And then also let's look at the loudliness of the song. So if you go here, you can see the loudliness measured in decibels. Okay, so we looked at it previously, and it's here measured in decibels. So okay, when the decibels are around -15 to around 7 people like such songs, and then people begin to dislike it when it becomes extremely loud. Okay, and people dislike means come extremely quiet. So that's for the loudliness, and this one is for the acousticness. Okay, I have no other thing to say about acousticness, but you can read about what acousticness means and do some research, and then make your own conclusions from that graph. So let's look at the danceability. So I think people like songs that are more have a higher danceability than songs that don't have a higher danceability. It's quite I think it's quite balanced in both directions, as to say. But for me, if I was making a song, I have danceability of around 0.7. So let us know in the comment section below whether I like songs that are more danceable or songs that are more chilled and tuned. Okay, duration, this is milliseconds, so not much to say about the duration. I think people like songs. I don't think the duration of a song really matters from my point of perspective. Even from the graph, I don't think it really matters. I just think like the more if you vibe with the song, then that's it. I don't think that danceability matters. So let us know in the comment section below what you think. And also the energy, I think energy is from 0.4 to around 0.8 are more good. You can read about energy, what energy means. So here energy measures from 0 to 1 and represent a perceptual measure of intensity and activity. Okay, so songs that are more contain more activities around 0.4 to 0.9 or 0.8 are more liked. Okay, and the ones that are too much energy are kind of disliked, and the ones that less energy are not liked at all. Okay, about the instrumentalness, I have nothing to say here. About the liveliness, it's also quite balanced. About the speechiness, and what the speechiness means, I think the speechiness is the number of words in the song, right? I think we went over it. So speechiness are spoken words. Yeah. So I have nothing much to say about this. Let us know in the comment section what you think about the speechiness. I don't have much to say. So for valency, like positive attitude, so yeah, this is quite balanced. So if the song gives you more positive attitude, then you probably like it. Yeah, so people like more positive songs than negative songs, and that's quite good. Yeah, so guys, that's all for this video. So we went about analyzing the Spotify data set. We had a list of questions, and we went ahead and tried to answer all of those questions. So now it's time for you to practice what you have just learned, right? So you just don't watch videos and go away with it. So try to learn something from it, and try to do this self-assessment and try to answer these questions on yourself. Let us know in the comment section anything new that you have discovered from the data that we didn't go over. And if you're new to the channel, please kindly consider liking, sharing this video, and subscribing to the channel. That supports me and keeps me motivated making this video. Okay, if you have any suggestions what I can do on future videos to improve the quality of the content and engagement, leave a comment in the comment section below. I'll do my best to implement those. So guys, thanks for watching, and see you in the next one. Keep safe.